Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this question belongs to paper 9709/45 for the session May June 25. Let's go through the question. Question number 7, which is the last of all questions of this paper. Two particles A and B of masses 6.5 kg and mkg respectively are connected by a light inextensible string that passes over a smooth pulley. The pulley is fixed at the top of a rough slope which is at an angle of alpha to the horizontal ground, where tan alpha is equal to 5 over 12. A is on the rough shape. A is on the rough slope and B hangs below the pulley. See the diagram. The coefficient of friction between the slope and A is zero point 0.4. Given that the system is in equilibrium, find the set of possible values of M. Well, before moving on to the solution, first of all, we will have to pick up the concept. And the concept is, whenever a particle is held equilibrium, we know that there are two possibilities, two cases. What are the cases? One case is the particle is supposed to slide down. The particle is about to move down, or the particle is about to move or slide up. These are the two possible cases. Well, one after the other, we will have to analyze both the cases. But before moving on to the solution, first of all, we will have to know the components. Well, for the components, let us complete the diagram first of all. So, if we complete the diagram, let me zoom it out. Well, then it is going to be, as the plane is rough, first of all we'll have to find normal reaction force. For that, let us complete the diagram. So this is weight, this is weight, not this ink, we will have to use different ink. This is weight. Weight will act vertically downward, and this is the normal reaction. Normal reaction. Let me erase these unnecessary parts. Well, then this is, so this is a 90 degree, and angle is alpha. Our angle is alpha. Well, as the plane is rough, first of all we'll have to find normal reaction force. So normal reaction force, there is no upward force acting on particle A, so it is r plus 0 is equal to now downward force. What is the downward force? Downward force is mg cos alpha. And for cos alpha, look, the value of tan alpha is given. From that we will find cos alpha. So let me draw a triangle over here. The triangle is this. This is the right angle triangle where angle is alpha, and they have told tan alpha is 5 over 12. That means 5 over 12. If vertical line or opposite is 5 and adjacent is 12, so definitely hypotenuse is going to be 13. And 12 square plus, let me show you, it is actually 12 square plus 5 square. So our cos alpha is equal to 13. Okay, so our cos alpha is going to be adjacent over hypotenuse. Hypotenuse is 13, adjacent is 12, so it is going to be 12 over 13. Let us write here, or r is equal to mass of the particle is 6.5, acceleration due to gravity is 10, 6.5 into 10, and cos alpha just we have found, it is 12 over 13. Well, hence our R is normal reaction is going to be it is 65. So 5 3s are 65, 5 12s are 60. So it is 60 Newton. 60 Newton is the resistance to motion, I mean normal reaction force. Well, now we are going to apply our concept. As we have already decided, there are two possible cases. One is the particle was about to move down, either about to move down or it was about to slide up. Okay, so let us write one after the other. When we will start writing here, yes, when A is about to slide down. Okay, already I have explained that whenever a system is held equilibrium, there are two cases. One is the particle is about to slide down, or the particle is about to slide up or move up. And we are considering A. Let us discuss B later on. First, A. When A is particle A is about to is about to slide down, about to slide down, slide down, slide down. Okay, so let us analyze the scenario. Let's analyze the concept. When the particle is about to slide down, what does happen here? Look at this. When the particle slides down on the rough surface of plane, then what are the forces? Because we are going to apply the concept of the motion law of Newton. So let us see which force is causing the particle move down. There is no force except weight. Only weight is causing the particle A move down. So let us write the concept we are going to apply is the motion law of Newton. So when the particle slides down, about to slides down, it is driving force minus resistance force is equal to mass into acceleration. So driving force, as we have already seen, here there is only one force which is causing the particle slide down. What is that? That is weight. Only weight is causing, as weight is acting as driving force. So weight is, we know, mg. Weight is mg. For this one, this is our direction. This is definitely in term of the triangle, it is vertical side or opposite side. So it is mg sine alpha, mg sine alpha. Then rest of the forces, look at this. The particle was about to slide down, and only weight is trying to slide the particle down, but rest of the forces are causing resistance to motion. So what are the rest of the forces? Number one is tension. Look at this, there is a tension in the string. So tension is here negative force or opposite force. Then there is another force which is causing resistance to motion, which is our frictional force. And we know the formula for frictional force is mu r. Mu r equal to mass into acceleration. As the system is in equilibrium, so there is no acceleration at all. Right side is 0. Now let us see how much is sine alpha is equal to. We have written cos alpha is equal to cos alpha. Cos alpha is equal to, we have already written, it's 12 over 13. So surely sine alpha is equal to 5 over 13. Cos alpha was 12 over 13 and sine alpha is 5 over 13. So we are going to just substitute the values. If we apply the values, it will be mass of the particle A is 6.5. Look at this, here it is written 6.5 kg. So 6.5 into acceleration due to gravity is 10 and sine alpha is 5 over 13. We have just written minus tension. Tension can be written on the other side or let it remain unchanged. Minus mu is our frictional coefficient. Our frictional coefficient is 0.4. So it is going to be 0.4, and our normal reaction force, I mean R, already we have obtained the value of R. Our mu is frictional coefficient, which is zero point 0.4. So zero point 0.4, and our R is that is normal reaction force, which is 60 Newton. Okay, so let us substitute as 60. It is 60 equal to 0. Now if we isolate our T will be on the other side. It is 6.5 into 10 65. If we divide 65 by 13, it is 5. So 25 minus 4 sixes are 24. So it is going to be 24. If we multiply 60 by 0.4, it is 24, and T can be isolated. Hence, this can be our equation number 1. Already we have come to know that there are two possibilities of tension. Hence, our T is going to be 1 Newton. 1 Newton. Okay, this is one of the possibilities when all the forces are resistance force except weight. Okay, the second possibility. So for the second possibility is, what is the second possibility? We know that this is the tension when the particle was about to move down. Now what is the tension? We will find the tension in the string. Then what is the tension when the particle was about to move up? So let us write it in word. When a particle A, when A is to about to move up, slide up or move up, whatever you write, slide up. Okay, the same concept we are going to apply. It is going to up. So driving force minus resistance force is equal to mass into acceleration, the same concept. Well, now let us see what is the driving force, and we can leave this as equation number 1. This is first tension is equation number 1. Okay, then let's see what is the driving force when the particle moves up. When the particles move up, look at this here. This is the particle. Okay, it will move up. So when a particle is moved up, there is nothing but the tension is the driving force, and rest other forces are trying to slide it downward. So our driving force is tension, then tension minus tension in this string, that is tension minus. So what are the next forces? First force is frictional force. Frictional force is, we know, mu r minus the other force, which is trying to, the other force, this is the particle. Okay, the other force which is trying to slide the particle downward is weight. So weight is mg sine theta. Mg sine alpha. Sine alpha is equal to mass into acceleration, which is 0 because there is no acceleration at all. Well, then T minus, our mu was zero point 0.4, and we have already used our normal reaction force, which is 60 Newton. So let us write 60.4 into 60. 60 minus mass of particle A is 6.5 into acceleration due to gravity is 10, and sine alpha we have already used. Sine alpha was 5 over 13. So it is 5 over 13. 5 over 13 equal to 0. Hence our tension is going to be, hence let it be the last step for this part. Tension is equal to, it is 24. So 4 6s are 24. 24, and this is also plus, and 65 divided by 13, 5 5 5s are 25, means it is 49 Newton. So there are two cases, two values of tension. Look at this. One is the least value, the other one is the maximum value. Here tension is the external force which is actually holding the particle in equilibrium. Well, now the question is, look, we are not supposed to find the value of tension. They have told us to find the possible values of m. Look at this, we'll have to find the possible values of m. This is our value to be obtained. We are still far away from m. Let's see what is m. M was actually what? The mass of particle b. This is m. Well, then particle b, look at this. So long we have been analyzing the scenario or for different forces of a. Now b. Okay, for b it's actually very simple. Let me write over here. No, let me write over here on the right side. Okay, so if I draw a line segment over here. Okay, so for a, now when b moves up or down, okay, it's all about b. Now when b moves up or down, now you may get confused that why should it be up and down, same scenario. The concept is, suppose we are considering this to be up, okay, then our concept is driving force minus resistance force is equal to mass into acceleration. Mass into acceleration. Now let's see what is the driving force when the particle B moves up. Look at this particle B. The external force acting on B is nothing but the tension in the string. Only string is acting, and the opposite force is weight. So there are only two forces, and one must be equivalent to the other one. As there are only two forces straight away, that's why whether it moves up or down, it will be actually same. So let's see, if it moves up, then tension is the driving force. Tension is the driving force. So tension minus, what is the force moving it, causing it? Resistance or trying to move it down? Nothing but weight. Here only weight is acting downward. So minus weight is mg. Mg cos 0 degree. Okay, because it is vertically downward, that is perpendicular through the perpendicular line. That's why angle is 0, or sine 90, whatever you tell, equal to mass into acceleration is 0. Hence our t, here we can write t equal to mg cos 0 degree. Okay, so this is not the last step. It should be, it should not be the last step. It should be one more step. It is T is equal to tension in the string is particle B. Look at this. The mass of particle B is m. Here it is uncertain. So if it is m, let us write m into 10. M, that means 10m. Okay. And if we look at this, cos 0 degree is 1, so 10m, 1s are 10m. So tension in the string is 10m. Now let's see whether if the particle moves down, what would happen. Actually they are same as I have shown. Look at this, the upward force is tension, downward force is nothing but weight. So ultimately they are equal to each other. There are no other external force acting on B. That's why whether it moves up or move down, its tension will be same. That means there are only two forces, they are equal to each other. It varies on the basis of the variation of mass. Okay, so tension is equal to 10m. Now if we go back to the equations, look at this. When t is, first t was 1, so we can apply this one. When t was 1, when, or not when, we will write t equal to, t is equal to 1 when m is equal to, look at this, what will be m? Mt is 1, so 1 over 10 equal to what? Equal to zero point 0.1. And t is equal to, what was the second value we obtained in the tension? Second value was 49. When t was 49, t is equal to 49 when m is equal to, same, it is tension is 49, so 49 over 10. means it is 4.9, not there. Let me write just below this. It is going to be 4.9. Now let's see what does this mean. There are two values of m, 1.1 and 4.9 kg. Now let us analyze these two values. What does it mean actually? In first case, we have got that the value of m is zero point 0.1. In the second case, we have got the value of m is 4.9. It means actually if the value is, when did we get zero point 0.1? When tension is 1 unit, 1 Newton. Look at this. That means if the value of, if the value of m, if it is more than zero point 0.1 kg, then the particle would slide down. That means both the particle b would move downwards. If the value is less than zero point 0.1 kg, if less than zero point 0.1 kg, then b would move up. Look at this. If the value of b, once again I'm repeating, if the value of b is more than 1 point, less than, sorry, less than 1.5, then it would move downward. Okay, so, and if the value of b is more than 4.9, the second value is more than 4.9, then the particle would move down. So it's very simple. Once again I'm clarifying. If the value of b is, I mean mass of b is zero point 0.1, less than zero point 0.1, then the particle would move up, b would move up. If the mass of particle b is more than 4.9 kg, then particle b would move down. That means both of the particle slide, b, a would slide upward and b would move downward. That's why they have told us to find that, so that the particle, the system is in equilibrium. Look at this. Equilibrium, as the system is supposed to be equilibrium, the mass of particle b will be in between zero point 0.1 and 4.9. So how should we write the value of this? Then we can write the minimum value should be, minimum value of mass of particle b should be zero point 0.1. Hence let us write the range of the value is going to be from 0.1 until 4.9 kg. If the value, I mean mass of particle b is ranged from 0.1 kg until 4.9 kg, then the system will be in equilibrium. Otherwise, if it is less than zero point 0.1 kg, then the particle A will slide down. If it is more than 4.9 kg, then particle A will slide up, I mean B will come down. So that's all about the solution to this part. Let's move on to the next part. The next part of the solution says, it is on the next page. Yes, it says, it is given instead that m is equal to 12 and the particles are released from rest with a string taut. Use an energy method to find the speed of the particles when each particle has moved zero point 0.6 meter. You may assume that this occurs before A reaches the pulley or B reaches the ground. Well, so they have already indicated the concept. Concept is energy equation should be applied. So for energy equation, the components are, we know, height as well as velocity. So initial velocity of both of the particles, they were in rest initially, and final velocity can be obtained. But about height, okay, so we will have to determine the height. They didn't give height, so please don't get confused with this one. This is has moved 6 meters. That means this is their movement, but this doesn't mean height. Let's see what is the scenario. For that we will have to, if I erase this, let me zoom it out. This is the figure, okay. and I'm going to erase these unnecessary parts. And or I can show you drawing two different figures. For A, look at this. For A, I mean, A was lying on a plane. Okay, suppose this is, here is the particle A. A is over here, and yes, so this is for particle A. Okay, it moved zero point 0.6 meter. Look at this, it is written here how much. 0.6 meter is the length it traveled. So this is our 6 meters. Yes, so for B, this is B. Okay, for particle B, for particle B, and angle is alpha. Okay, for particle B, it moved up zero point 0.6. This one is 0.6. Okay, and now we will have to find, actually we require height. Okay, let me change the ink. As I have told, for energy equation, that one of the components is height, so we require actually height. This is for B. Okay, so our height is to be obtained. This is our height. So height is equal to what? We know height is equal to hypotenuse, then sine alpha. Okay, sine alpha. So height for B, height of B, okay, B is not necessary to be written. So it is zero point 0.6 into sine alpha. From the previous page, we can find our sine alpha was sine alpha. Look at this sine alpha. We have used sine alpha is equal to 5 over 13. So it is 5 over 13. Let us write 5 over 13 here. 5 over 13. So 5 over 13. 5 over 13. So finally, how much is it going to be? It is 0.65, it is 30. I mean 3 over 13 is the height for B. Now for A, height was, it is simple, because for A, if we talk about for A, okay, A was, I mean for B, sorry, it was for A. I made a mistake here. It is actually A. It was particle A actually, because A was lying on the slope. So it is not B. Let me write over here A. It is A. This is A. And for B, B was actually moving up. Okay. Or down, whatever. It may be up or down. We require to write here. Let's see whether they moved up or down. As mass of particle is 12, in the previous question we have found if it is more than 4.9, then B will move down and A will slide up. As B is more than 4.9, definitely B moved down. So downward, and it was hanging vertically downward. So for B, it is simply here, it is going to be how much? It was zero point 0.6. 0.6 meter was height. Okay, not this one 0.6. It was straight away, not according to the triangle. We will write here. It is just height of A. B. Height of B is equal to zero point 0.6. Well, now we are going to apply the concept they have told. They have told us to apply the energy equation. So let us write energy equation. So energy equations of work done by driving force minus work done by resistance force is equal to change in GPE, as there are two particles. So GPE of A plus change in GPE of B, gravitational potential energy of B, plus change in kinetic energy of particle A, plus change in kinetic energy of particle B. Well, now we will substitute the values. first of all, let us see whether there is any driving force or not. If we consider the system, look at it is actually they are connected with each other through the string in between them was working as driving force and resistance force. So as there is no other external force, driving force is zero. Remember, if there is no external force acting on the particles, then driving force is zero, so work is also zero. Now resistance force, for particle B there is no resistance force. For particle B it was just hanging, so there is no resistance to motion. But for particle A, as it was lying on a rough surface, so definitely there is a resistance, I mean frictional force, which is external force. So our frictional force is Fr into S. We know work is equal to force into displacement. And change in GPE, so change in GPE is mgh of A plus mgh of B plus kinetic energy. We know the formula is half of mv square of A plus half of half of mass of A into final velocity of particle B square. Now we will apply the values. What are the values we do have? Look at this. The first one is frictional force. Frictional force is mu r. We have written mu was zero point 0.4, and our frictional force was 60 Newton. I can show from the previous page. And S, actually the each of the particle moved 6 meter, so 0.6 is equal to mass of particle A is 0.65 and acceleration due to gravity is 10. Then H, we have already written the particle A was moving downward. How long? 0.6 meter. It was moving downward. Okay, so for downward, actually height means it's difference between the initial and final height. Final height is 0.6 meter, so initial height was higher. Actually it was moving downward, so it should be negative. It should be negative. So negative symbol can be written over here. If we use here negative symbol, negative, then by erasing this I can write it more clearly. Let me erase this. So it is equal to minus 0.65 into 10. This is for particle, sorry, this is for particle A, not particle B. I made a mistake actually. 0.65. So for particle A, it was already we have found it was how much? 3 over 13. For particle A, height was 3 over 13 and it was moving up. Remember, if B was moving down, so A was sliding up. That's why it is final height is more. That's why it will be positive. It is how much? 3 over 13. 3 over 13. Let me show you again. It was 3 over 13. Then for mass of particle plus mass of particle B is 12 and acceleration due to gravity is 10. Then height must be negative. Okay, negative how much? Let us write here negative how much? As I have told, B was moving downward, that's why the final height is getting less, so it is negative. 0 minus 0.6 is minus 0.6 minus 0.6. Well, after that, plus half of mass of particle A is 6.5 and final velocity is to be obtained. Initial velocity is 0. That's why there is no necessity of subtraction. Plus half of mass of particle B was 12 and velocity was same. Actually initial was 0, final was v square, I mean final was v. Then if we simplify this, it is going to be 4 6 24, 24 6 are 40. So 14.4, it is negative 14.4. Negative symbol should not be ignored. It is negative 14.4 is equal to here 65. If 65 is divided by 3, that is 5. So 5 threes are 15. It is going to be 15 plus, for the second case it is 120, and if we this is actually multiplication. Look, if we multiply one, it is 72 actually. 120 into zero point 0.6, that is 72. 72, then plus, but it should not be addition, it is going to be subtraction. Let us use subtraction symbol because it was a negative symbol, height was negative, so it is negative 72 plus here 6.5 and 12, it is 18.5. So half of 18.5, 18.5 over 2, then v square. Well, so if we calculate this, 15 is going to from 72. If we subtract 15, it is 57. So 57 is negative, it is going to be positive. So let us write 57 minus 14.4. Okay, is equal to, it is going to be 9.25, isn't it? 9.25 v square. So finally our v is going to be, sorry, our v is going to be, or v is equal to, v is equal to, from 57 if we subtract 14.4, it is going to be 34, isn't it? 32.6, 32.6, and then it is going to be 9.25, 9.25. Hence our velocity is going to be, our velocity is going to be, v is equal to, hence v is equal to, our v is, let us do this calculation, 32.6 over 9.25. Using our calculator we will get 32.6, sorry, we made a mistake, it's not 32, it will be 42.6. Okay, so let me write here 4 instead of 3, it is 42.6. Okay, so we will divide square root of 42, 426, 925. So 426 square root of 4, 146, so it is 2.146. If we round it up to three significant figures, it is going to be 2.15 meter per second. So this is what the final velocity of B should be, and that's all about the answer to the second part of the question. And I tried my level best to explain every tiny part, and I believe that if you have been attentive to the fact, then you have understood. May Allah bless us all with the beneficial knowledge. Allah Hafiz. Let me show the second part again. Yes, this is what the second part. Simply, we have applied the work energy equation, and for the first part, we have applied the method of, there are two cases. One is the when a particle is held equilibrium. There are two cases. One is the particle may slide down, was about to slide down, or was about to move back, I mean slide up. In these two cases, two values have been obtained for B, and if the value of B, I mean mass of B is more than zero point 0.1, then it would, less than zero point 0.1, then it would slide up. If the mass of particle B is more than 4.9, then it will slide down, I mean move down. That's all about these two solutions. Fi amanillah.